Assalamualaikum and greetings to all. Today's topic is on triple integrals in cylindrical coordinates, where the variables that we're going to use would be r, theta, and z. So here, let's look at this theorem. Here we have a solid G. So what we're going to do is we're going to project this solid G onto the xy plane, and usually we use cylindrical coordinates if the region that we project our solid onto is part of a circle or the whole circle or the cardioid shape. Then we use cylindrical coordinates. Okay, the order of integration, this dv here, well, first of all, our function f should be in terms of r, theta, and z. And the relationship between x and r and theta is similar to polar coordinates, where x is r cos theta, y is r sin theta, x squared plus y squared is r squared, and tangent theta is y over x. How to measure theta is still very much the same as polar. We start from the positive x-axis, anti-clockwise direction, and r is measured from the origin, a straight line across your region, and z here is still z. It's measured as the top surface and the bottom surface. Alright, so back to our triple integrals here. So here our function, if you have x, y in it, you have to change it to r and theta using this relationship. And then for dv, the iteration would be integrate with respect to z first. So the upper limit for z is still the top surface, and the lower limit for z is still the bottom surface. And our dA here now would be integration of a solid, of a region R, which is going to be on the xy plane. So your dA now will be r dr d theta, just like polar coordinates. Okay, all right, now let's look at example. Excuse me. Okay, so here we have example 4, where we are asked to find volume of a solid bounded by, so here we have one equation that would be paraboloid, and here we have x squared plus y squared equals 4. This is a cylinder, but I will show you how to plot the surface or sketch the surface. And here we have z equals 0, which is the xy plane, horizontal, and we are asked to use cylindrical coordinates. Okay, I need more room than this. Okay, so here we have, let's plot z equals x squared plus y squared first. Okay, so remember in mathematical methods 1, where you've learned how to sketch level curves and traces, that would be view of your solid from above, from the side, and from the front. Okay, all right, now let's look at what would the view of your solid be if you look from the front. So from the front, you let x equals 0. So when you let x equals 0, then your equation here would be z equals y squared. So if you plot that on the yz plane, what you get is a parabola that open upwards. So this is the view, oops, y, that should be z here, on the yz plane. Okay, so you have a parabola open upward. So this is the view from the front. Okay, now let's look at the view from the side. From the side would be this way, where y is 0. Okay, now if we let y equals 0, then our equation here, that would be z equals x squared. And if we plot this in 2D on the xz plane, we also have a parabola. So that would be the view from the side. Okay, now let's look at the view from the front. The view from above. For the view from above, you let z equals a constant. Well, if you let z equals 0, then you just get x squared plus y squared equals 0, which is just the origin is a point, really, the point at the origin, or this is just a circle of radius 0, so you can't tell much from a point. So it's better to pick another value of z. So let's say you let z equals a constant 4. Okay, so if you let z equals a constant 4, then the equation would be x squared plus y squared, this equation here, x squared plus y squared equals 4. So that is a circle on the xy plane. If you plot this, you have a circle of radius 2. So here we have a circle of radius 2 if z is 4. Okay, now let's sketch the whole thing. Okay, now what we do is, here we have x, y, z space. Okay, now we're going to plot our surface using these three one level curve and two traces. Okay, now let's look at the view from the front. This is the view from the front where we have y and z. Okay, so y and z would be here. This is z and y. Okay, we're going to plot a parabola. So we have a parabola open upwards like so. Okay, and if you look at this trace here, this trace is on z equals 4 plane. Okay, so if you z equals 4 would be a horizontal plane. So let's say this is z equals 4, and what you have is a circle of radius 2. So let's say this is a circle of radius 2, so that would be a 2, and here that would be a negative 2. And this is the view from the side. The view from the side, you can see that we have a parabola as well. So when you connect all the view from the front, view from the side, and the view from above, what you get is a parabola. So this is an equation for z equals x squared plus y squared. Okay, now let's sketch x squared plus y squared equals 4. This would be a cylinder, but if you don't remember that, let's sketch the equation on 2D first. So x squared plus y squared equals 4 is a circle of radius 2. So we have a circle of radius 2. Now, if you look at the equation here, it doesn't have z in it, meaning that it doesn't matter what z is, you have the same circle. So here, let's say this is the z axis, y axis, and x-axis. So let's sketch a few circle on different values of z. So here we have z0. Z0, we have a circle of radius 2. See, that's a circle of radius 2. And on z equals positive plane, we have a circle of radius 2 as well. So when you connect all the circle, so we have 2, negative 2 here, we get upright cylinder. So this cylinder is governed by the equation x squared plus y squared equals z. Equals 4. Okay, so now we have another surface, which is z equals 0. So z equals 0 is just a horizontal plane. Okay, now we're gonna put these two surfaces together. We have the upright cylinder and we have the paraboloid, and then we have z equals 0, which is a horizontal plane. Okay, we're going to put everything together. Oops, should be y. And here we have z. Okay, so we have a cylinder. First we have a cylinder. The radius of the cylinder is 2. So let's say here we have a cylinder, radius 2, 2, and negative 2. Okay, and then we have z equals 0, so we don't draw the cylinder below the xy plane, and then it goes up. Okay, but then as it goes up, we have this surface here, z equals x squared plus y squared. So say here we have the surface, the paraboloid. So it doesn't go up forever because we have this paraboloid here. Okay, so this is our surface where we have, so this equation is z equals x squared plus y squared, and at the bottom we have z equals 0, and on the side we have the cylinder x squared plus y squared equals 4. So now we want to find the volume of the solid. So we want to find the volume of the solid. So what we're going to do is we're going to project our solid here onto the XY plane. So when we look at our solid here, when we project our solid onto the XY plane, what we get is a circle of radius 2. Excuse me. A circle of radius 2. Then from our theorem here, we have to integrate with respect to z first and then figure out what is the top surface and the bottom surface. Okay, so if you look at our solid here, if you draw a straight line parallel to the z-axis across your solid, then you can see that it crosses, the top surface would be the paraboloid, and the bottom surface would be the z equals 0 plane, okay, or xy plane. Okay, let's find the volume. Okay, from before, volume is equal to dv of a solid G, and we're going to use cylindrical, meaning that we're going to integrate with respect to z first, and our area A would be on the xy plane. Okay, now let's get the upper and the lower limits for z. The upper limit for z would be this paraboloid, which is governed by that equation. Okay, so we have z is x squared plus y squared, and the lower limit would be the xy plane, which is z0. Okay, but then we're going to use cylindrical. So if it's cylindrical, we cannot use x and y. That will be changed to r and theta, and dA here will be replaced by r dr d theta. Okay, so we're going to use cylindrical. So upper limit for z would be r squared. Remember, x squared plus y squared is r squared. Okay, and our dA here, that would be replaced by r dr d theta. Okay, now let's get the limits for r and theta. Now going back to our solid here, if you can't see the limits for r and theta, let's sketch this in 2D. So here we have x, y, and then we have a circle of radius 2, 2, 2, negative 2, 2, and our region is this one. Okay, so looking at this region R on the xy plane, you can see that R is from the origin to this circle, and this circle is governed by this equation. But we know x squared plus y squared is r squared, meaning that r is 2. So r is from 0 to 2. Oops. R is from 0 to 2. And for theta, remember how you measure theta is from the positive x-axis anti-clockwise, and as you can see, it's the whole circle. So theta is going to be from 0 to 2 pi. Okay, now let's evaluate this. Remember, we evaluate this from inside out. So the first integration would be with respect to z. Oops. So if we integrate with respect to z, we consider the other variable as constant. So the other variable here is r. Excuse me. So that will give you rz. Replace z with upper and lower limits. Okay, then we get, oops. Excuse me. Replacing z with upper and lower limits, then we get r squared minus 0, and then r squared times r is r cubed. Okay, next is integration with respect to r. So that will give us r to the power of 4 over 4. Replace r with upper and lower limits. Then we get 4 to the power of 2 to the power of 4 is 16, divided by 4 is 4. So we have 4 d theta. Integrate 4 with respect to theta, we'll get 4 theta. And then replace theta with upper and lower limits, then we get 8 pi. So the volume of the solid is 8 pi. So here we project our solid G onto the xy plane, and then the region here, in this case, it's a circle. So your dA, so it's better to use cylindrical. So instead of x and y, we use r and theta. So in this case, x squared plus y squared is r squared, and dA is r dr d theta. Then evaluate as usual. then you get your volume. Okay, that is example 4. Right, I'm gonna save example 5 and 6 in our next video. Thank you.